All right, everybody, welcome to Udacity HTML5 game programming, the study group that we've been having for the last, well, this is our 7th week. So for all of you that are still here and those of you on the live stream, welcome back. You're the hardcore of HTML5 game developers to be. Thanks again. So we're here live in San Francisco, and first a quick round of applause for Google's great food that we had today.
Yeah, seriously, it was amazing.
It's getting better and better. I'm just looking forward to next week.
That this is going to end.
We only got 8 weeks. We need like 17 more weeks.
Panna cotta dessert.
Actually, it's probably better. I put on a lot of weight, actually.
It's the Udacity 15.
It's the Udacity 15.
Who said there wasn't part of the college experience, right? Right. So, a couple of updates. So last week we had guests, and they're on the live stream now, I know, from Guatemala. Right?
Yeah.
And today, that got even better. We have special guests from China right here.
Yeah.
China? Round of applause for China.
And also over there from Korea.
Yeah.
Korea?
So,
We also have
amazing.
We also have one from Vietnam.
Yeah,
too.
we also have a guy from Vietnam.
Round of applause.
all right.
All over the place.
Las Vegas.
Yeah, Las Vegas.
So we have in person.
We don't have to start that yet.
No,
Cold Step.
No, we don't have to start that yet.
I think we do.
Everybody, round of applause for my father driving all the way out here today. Yes.
It was really hard. It's good to know who to blame.
Yeah, there you go.
All right. So wanted to kick off the show again with a quick, or not so quick, diatribe by Colt. But before we do, a couple of quick announcements. The sponsors for this event, as I mentioned, Google for the venue and the great food. We also have the HTML5 user group, the San Francisco HTML5 user group that I'm sure by now you're all a member of. We're actually just really excited to have our 7,000 member just joined a few hours ago. So that's pretty exciting, and on top of that, we have let's see here. Oh, never mind.
Never mind that sponsor.
Never mind that.
Thank you for your money.
Google Developers Live. That's what it was.
GDL,
Google Developers Live for the mobile setup here, which is getting better and better every week.
Yeah, it's getting even better.
So tonight,
These guys over here.
that's right. Thanks, man.
You know, the funny thing is these guys come in every week and they put up with everything and they still look good doing it, right?
Yeah, it's really impressive.
Yeah, right. Yeah, there you go. Good looking guys over here. Ladies?
Yeah, seriously.
So one of the things I wanted to quickly check in with you guys on here in the room is how the contest is going. How are you progressing on that? Are there any people have anything to share about their contest?
Yeah, right there. Go ahead and come up to
You want
mine.
to go up to the mic? We have a mic wired up here.
This is a good story.
Okay, great. Okay.
I've been using Impact for like a year, and I didn't really know what was going on behind the scenes, and this class came around, and it was a really great opportunity for me to just learn what was going on. And we've got a shooter that's almost done, and I can show you guys later.
Fantastic.
Yeah, awesome.
Fantastic.
That's really cool.
Thanks, Paul.
By the way, he's only been programming a year.
Oh, nice.
So tell me, what were the parts of Impact.js that were causing you problems?
Just like background animations and stuff like that. I understood entities, trees, and everything, like just how that all worked, but just getting in there and just making sure it looked how I wanted it to look. I was just stumbling just from an experience, really.
Very cool. And did you have success using some of the plugins, like getting Box2D and Lawn Chair and some of those things working?
I am working on another game that's using Box2D.
Oh, perfect.
It's longer term, and we're going to use a lot of the stuff that we made for this for that.
Fantastic.
But, yeah, Impact does handle plugins well. Sometimes you got to massage it and just try again. But it definitely works. Yeah.
Very cool.
Nice.
Yeah,
Bravo.
Yeah, very cool. Very cool.
Fantastic.
Yeah. And that's generally true, I think, of most JavaScript libraries. You just kind of have to massage it until it works with everything you need it to work with.
True. How's your game going, Tony? Any progress
Well,
there?
my young associates
Mike.
got tied up at
Mike.
The world can hear you.
we're a team of the oldest guy in the room and the youngest guy in the room. And he was so enthusiastic about the HTML5 conference and probably went over the top when he saw Colt's presentation that he just couldn't make it tonight. So I don't know the answer to that question. We'll get something done.
Okay, yeah.
Fantastic.
Yeah.
Fantastic.
Speaking of which, the HTML5 DevConf is really amazing. I haven't had time to go this time, but I went last time I was in town, and a lot of great talks, great energy, like you've been saying. Colt.
Actually, yeah. Colt was speaking there today. How many of you in the room here went to HTML5 DevCon?
Couple faces. I see.
Okay, yeah.
You guys are awesome.
Yeah, so it's going on today and tomorrow, and then Wednesday, as sort of part of the HTML5 DevCon, we have a web platform doc sprint. So it's right here in this room. Actually, we're going to pack the room. We have a lot of people signed up, but if you're still interested, let me know. Yeah. Okay, so before we jump into the questions, wanted to let the ever popular story time with Colt.
Hashtag.
Hashtag. Trademark.
Story time with Colt.
We've actually been seeing that hashtag pop up on Twitter in a couple different places. It's a little bit interesting. Find that awesome.
That one picture is fantastic.
Toggle over here.
Fantastic. Hello, everyone. Time for story time with Cold. Hashtag. So first off, I've been getting badgered over the past couple weeks for my latency and actually getting to you guys a fantastic set of book resources that I recommend for all budding programmers. Here is a shortened link. I actually put the list that I recommend up on my G+ profile so that everyone can go check it out. What's been really interesting about it
a lot of good
is how many other books have been recommended. These are other veterans in the industry, guys like Mike Acton, Rich Geldrich,
John McCutcheon.
Yeah, exactly. As well as Branimir is on there too.
Yeah.
So it's a fantastic book list, and I have a feeling the more people kind of look at it and listen to it and share it around, the larger that list will grow until maybe we actually need to do something legitimate with it. But in the meantime, check out this URL. It's a fantastic list of resources for you. Let me actually see if this thing works today.
And that URL should also be linked to from the email that was sent out earlier today. So, in case you need it.
In addition to that, so with the talk we did today at the HTML5 DevConf, we've been getting a lot of great feedback from individuals looking to know more about how to do really hardcore web performance. So there's actually a Google Plus community out there for web performance. If you'd like to actually subscribe to that and start listening to the stream, there's really just some amazing minds doing some cutting edge stuff there. And it seems to be a nice focal point for a lot of us to actually push through our data and our thoughts and our research. So here's another URL if you guys want to.
Did you pick that URL on purpose, like S later?
Oh no! That's just sometimes Google just converges in awesomeness. You know, I actually wanted. So I had an idea. I actually wanted to write a shortener algorithm that would like use a binary search to try to figure out what web page had LEET L33T as the shortened version. You know, and just kind of be like, well, no, that's too high, that's too low. But unfortunately, I had other things to do. Okay, so fantastic. So this week was sound unit. Yes, sound. Everyone loves sound. It's good to hear you all. Peter has done a fantastic job of explaining all the underlying architecture and the APIs in Web Audio API for sound, but what I wanted to talk to you guys about today is how is sound used in games? More specifically, sound positioning in games, because this is probably one of the trickiest things to get right, and if you do it wrong, you'll do nothing but confuse your user from here to the end of time. So the first thing we have to come to terms with is that if you have a user, they usually have some visibility on their screen. So in Grits, we actually take a top-down approach to everything. So if we actually put your little robot right in the middle, you view the rectangle around him as the actual screen that is visible to them. Well, the question we have then is, what is all of this other area around them? What we actually do to determine if sounds are visible to the user, right? Because if they happen on the screen, you would expect to see a bomb explode or a tripwire actually fire. But when something happens off screen, we have to go through the logic process of what does that sound like, right? Because we actually have this interesting physics phenomenon that the farther away a sound is, the less we hear it, or there's a delay or some other interesting properties. And so we actually try to emulate that in the Grits code base. So what we actually do is we define the sound rectangle of max distance of sound as actually twice the screen width, right? So what this ends up doing is if a sound is actually played outside into this other area or off screen, we can define and actually get its linear position from the user by dividing its position or getting its distance and then dividing that distance from the actual max distance, right? So this actually gives us this really nice little algorithm here, where we actually divide the distance to the sound divided the max distance from the user, invert that, and then we have sort of a clipping algorithm, right? So if the sound actually occurs on the screen, we play it at max volume. If it occurs off the screen, then we actually linearly slurp it out until, well, slurp, depending on if you're quadratic or cubic slurp, but separate discussions. We actually interpolate it out by moving between 0.5 and actually 0. So the farther away as it reaches this max distance, that actually goes to 0 where you can't hear it anymore. Now this is really important because if you're playing grits and someone grabs a pickup or a bullet item or something off screen, then, you know, depending on how close it is to you, it may be of strategic significance. I think we talked about this in story time with Colt in the actual unit, but Quake 2 was actually the first game that really used this the right way. In fact, for those of you who are purists like myself and believe that Quake 1 was the greatest multiplayer game ever created in the history of time, then you'll know that they broke a lot of things when they actually made Quake 2. One of the things they broke, first off, was slowing down the game, but number two was that you could actually, they designed the maps around audio cues. So as you were playing around, if you actually heard someone pick up armor shards, you knew that there was only one or two places that that person could be in the map. And the reason they did this was, of course, strategic value. You kind of get cues from everywhere. Now, in Quake 1, this was not a thing. The only way you actually heard positional sound data is if you were very, very close to the individual. So we're going to talk about how all this goes through. So what happens, so in grits this is fine, right? Because we have an open playing field and we really don't have occluders keeping us from hearing the sounds. But what happens if we actually have a sound that occurs on a different medium than the actual user, right? So let's say we've got a wall right here. As the sound plays, the waves are going to hit the wall instead of the user. The question is, how do we actually model this inside of our game setup? Well, one way we could do this is actually cast rays. We could actually say, hey, trace a ray from the sound to the player. Well, as we saw before, that would of course hit the wall. So the next question is, well, what if we could start doing interesting things where we actually do inverse tracing, right? Where you actually bounce a ray around the room a little bit until it see if it actually hits the user, which for the most part is actually how photon mapping works and other sort of lighting algorithms, right? A piece of light is actually emitted from some light source, bounces around the room a couple times, losing emission every time it does, and then finally lands at some local atrophy minima, right? Of course, this runs into a problem, right? Once we actually get a sort of a complex scene, the question is, how do we accurately trace the route from the sound location to the user location, right? So this kind of moves you in a different direction, especially when it gets super crazy, right? We have to start doing recursive backtracing to find the correct intersection point. In games, we don't do this. Thankfully, we don't do this. We actually go for something a little bit crazier as a data structure algorithm, but a lot easier to do at the runtime. What we do is a concept of binary space partition. So any first-person shooter fans in the house? Awesome. See, this is more hands this week than there were last week. That's fantastic. People are actually playing games now. Yeah. Awesome. I've inspired people to waste their time. Yes. So what we actually do for any sort of first-person shooter games, the entire environment is actually structured in a binary space partition where any two rooms that share a wall are siblings of each other. And what this means is that we actually end up with a unique data structure that we can hierarchically traverse to figure out things like visibility culling, physics calculation, and even sound culling. So how we actually define this is that any two rooms are actually children leaf nodes in a binary space partition. And then we actually define any open space, like a door that connects two rooms, as what we call a portal. From here, we can actually traverse this data structure and say that if a sound occurs in room A, and room A is touching portal 1, we then know that any other rooms touching that portal can also hear that sound, right? So if room A plays the sound, we look for anything else that has portal 1 in it. Thankfully, room B does. And so we know, just sort of as an off approximation, that room B should probably be able to hear this sound in some way, shape, or form, right? Now, now, in this scenario, these two rooms would actually be siblings under the binary space partition. Of course, they don't actually share a portal. So if a sound plays in room A, it won't necessarily be heard in room B unless you have some other sort of heuristic to determine, you know, this is loud enough or this is important enough, right? Because you always want some special logic that says, once a dude picks up quad damage, tell everybody in the room or everybody in the entire map so they know that death is coming. Now, this gets a little bit of interesting when we start, you can actually start seeing how once the map gets super complex, that this acceleration data structure actually makes a lot of sense, right? Because it allows us to quickly find the child node that the sound is played in, and then all siblings that may be able to receive contact information about that sound. So the next question is, and Sean actually had a great bring up about this. He said, well, hey, how do we actually modify this so that sounds emit different properties when you're in different rooms? So let's say, for instance, this is a bathroom over here and it's tiled. So you're actually going to get a very echo, very hollow, kind of like my voice now, reflective quality to it, as opposed to like a sandy courtyard, which may have an open ceiling and actually muffle some of the sound in that setup. This is actually a great question. It actually comes back to your art content creation pipeline. Usually when you're creating a binary space partition, you can then attach attributes to any child node in the graph. This allows you later to actually walk back through and say, hey, a sound has occurred inside of a tiled room. I can then go do some processing on it. So what happens here is that in most games, we'll actually define 4 or 5 sort of effect properties that are usually defined by graphs. And the graphs, much like as Peter went through and talked about, can define echoes, reverbs, muzzles, and stuff like that. And so we'll actually say, hey, this is a reverb or an echo. And we'll define the graph itself. And then as the sound is played, we'll actually look at the properties in the environment in which in the room, or the properties of the room in which the sound was played, and then attach those graphs to that sound. So this is a really cool thing, right? Because it allows us very quick traversal, very fast ability to find what we need, and a lot of pre-computation that allows us to work from a palette of graph sounds, right? So this is generally the way that every game uses sound today. And this was actually started back in Quake 1. It's modified itself a little bit over Quake 2 and through those first-person shooter games into what you're actually getting on the Xbox 360, PS4 style things today. If you're actually playing Team Fortress or anything off of Steam, you're seeing a variant of this in action because it's very, very fast, it's very efficient, and it's very low mental strain for people to understand. I think that's the last slide. So quick questions on how sound is currently used in games. Anyone besides Tony? Tony.
When you were in the entities unit, your first video in the unit said entities have properties. And one of them, the curious 5th property, was post something to Google+. Okay, it was just kind of a offhand thing, but it made you think about anything could be a property.
Absolutely.
So just to clarify things here, those properties on the previous slide are part of the entity. And then at the beginning of the game, do you then go through the entities and then refine that palette of effects and sounds? Is that how this would work?
So this would be a separate lookup table of key value pairs, where reverb, echo, muffle, and water are
No, but
keys.
what I'm saying is, when the art, the artwork, which is that tiled room, you're going to set properties on it.
Yes.
That's all you have to worry about as an artist or as a designer, is that piece of that asset will have properties.
Yes.
And is that asset represented in the game as an entity?
So there's actually 2 ways to do this. So the first way is that normally if you actually disable texturing on all your models, everything's just flat polygons, right? There is really no difference between concrete or grass or sand at a polygonal level. It's just all triangles, right? So what happens is we actually will generally go through and annotate that a texture ID, right? So sand 7, concrete 34, actually has an attribute for a material type, right? So concrete has a material type, sand has a material type, and as artists are going through and actually creating their textures, they're filling in this separate data structure that says what the material type is for that. Then what will generally happen is during the export process of your build step, when you actually go through and say export this map to disk, a smart programmer, most likely a bald smart programmer, will actually go through and try to figure out what the approximation of sound is in that room. So it'll actually look at all the materials in that room and actually say, okay, well, half of this is tiled and half of this is muzzled. You know, let me create some interesting permutation that makes sense of. Then it'll actually list all these sound graph properties out into the file itself, usually with the map, because each map may have unique sound characteristics based upon what properties are contained on the textures and models themselves. And then when it's loaded up, the game will actually say, oh, hey, you know, we define reverb as, you know, 3 graph nodes that push data through, and we define muffle as a different sort of graph structure like that. And then anytime a sound is played, it can quickly go back through those lookup tables and figure out what effect graph needs to be attached to it during its lifetime. So this is also really important too, like when you shoot a bullet and the bullet hits concrete versus hits metal versus hits sand, so that you actually get other things like the right effect. So when it hits metal, you should see sparks. When it hits sand, you should see sand. This is all contained in the concept of a material type. Anyone besides Tony?
Just to follow.
Okay.
So what you're saying is that in the process of conceiving of and designing a game, you can have a sophisticated or simple a process that's the build process. and that defines properties that are essentially associated with the materials. The entities, my question confused this. The entities basically have properties that represent other things than that, because you don't want to compute that sort of stuff while the game is loading or anything else. You want that pre-computed. Would that be the way of interpreting this?
The best way I would vocalize this is that entities have logic associated with them, some sort of compute step, right? So this piece of entity Onyx needs to think, right? What you're dealing with in a lot of these environments is static geometry, right? And so we're just creating a data structure for just basically containing static geometry and then adding properties to it. So static geometry properties completely different than entity thinking properties, and actually should be handled in two separate logic flows through your code paths.
Somebody besides Tony.
I think we should start a new Udacity theme, mean time to Tony. Right? Like, how fast do we get to the Tony question? We love you, Tony. Don't take it.
As far as the binary partitions, how far do you propagate that? I mean, in the diagram you showed, okay, you have two rooms that share a portal. Mm-hmm. But for example, in the map there, if you go back to the map, you could keep propagating room to room. So you go through the sandy courtyard, you go into the room next to it. If there's another portal, you can keep going. So I mean, does it just vary depending on what your game needs are, or is there some kind of limit you might want to try and limit yourself to?
It's mostly two factors in play. Number one, smoke and mirrors. Three factors in play. Number one, smoke and mirrors. Number two, design need. And number three is sound expectations. So smoke and mirrors is just like it works or it doesn't, right? The design need may say that when someone picks up quad damage, everyone in the map hears it.
Right. That doesn't make sense.
Even though it doesn't make sense, right? Like, I'm about to get shot. Like that. In fact, Grits does this. If you pick up quad damage, everyone hears it. But if you go pick up a health canister, you only hear it if you're within a screen of it, right? So that's the design property on it. Now, the material property comes through and actually says, like, what is the sound expectation? And so if you have, this is really modeled by the artists that are kind of scrubbing through the experience, right, with a map, the designers, and what they'll basically say is, like, if something occurs here and I have an entirely tiled hallway, then I should propagate my sound through that hallway to the end of the room and use it as a conductor, right? As opposed to like just hitting that and absorbing all the sound inside of it and not propagating it. So a lot of these things, think of them less as runtime algorithms and more like a forward head binary flag, or at least a suite of scalar values that are taken into account when you figure out where to propagate to.
I guess in some cases, I mean, it seems like it almost gets as difficult as that physics model you were showing with sound bouncing off the walls and everything. So, I mean, I guess that you would, for example, if you had the tiled room and then you had a sandy courtyard and then it had to go across a pool or something like that you're going to have to run a different filter for each one of the rooms it goes through, and when it gets to the point where the sound is too low, you drop it.
And that's the smoke and mirrors part, right? Which is that, like, how much energy you're going to put in this and how much your user's going to care, right? Like, how much is this effort going to actually sell another unit? Now, if you're playing like Assassin's Creed or one of the early MDX games or was the new Mark of the Ninja game, where sound is critical to understanding your environment, then yes, a completely physically accurate sound model is going to be critical to the gameplay. But if you're playing like Dance Dance Revolution, and you're just getting bombarded with music no matter what, it really doesn't matter the quality at that point or what's on.
Unless you're dancing in the bathroom.
Yes.
Okay.
Bon Jovi.
I think a key thing with this too is you mentioned that it can almost get as complicated as the rays bouncing off walls and everything. Depends on when it gets complicated though. With the binary space partition, it gets complicated beforehand, before actual runtime, for the most part. So you don't hit that complication at runtime until much later.
Yeah, if you're spending
really key.
If you're spending more than 1 millisecond a frame calculating the permutations of sound through your entire system, it's already too slow. Of course, that's in native code. So put that out there. Yeah. It's in C++ code. More questions about sound positioning?
Were we going to talk about memory in sound? Or is that a bit too much of a hairball?
We can talk about streaming and propagation and.
There's more talking about this binary space partition and how big it gets and how to deal with that. For example.
Well, you can go to the microphone and ask.
Sure, I guess I got two questions as I walked up. First one is, does it actually process the sound if there's no possibility that anyone could hear it? Like,
Now you're getting philosophical on us.
Peter, give this man a t-shirt. Give this man a t-shirt.
yeah, it's sort of a bear in the woods kind of thing.
That's fantastic. Wow.
Different one.
Yes.
And the other one was, how would you actually, like sometimes when you're playing a game, like a missile goes across the entire map. How could a missile, is it just point sampling the missile through the missile's trajectory as it's going from one room to another, you know?
Yeah, so
That's
typically in your entity graph, you'll have some notion of attachments, where you'll be able to attach some logical entity to another logical entity. And then as that entity changes position or manifests itself differently, all of the other entities kind of trail along with it. So good games have the ability to say, attach this sound to this entity. And then what'll happen is that sound's position will change as the entity's position changes. And then of course that flows entirely through the logic system. So what happens is, okay, let's dive deep on this.
Like a police car coming across.
Yeah, let's dive deep on this because I think this might help. So you've got a sound in memory, right? And the sound is effectively moving binary data through a stream processing system that the audio card is hearing and moving into the speakers, right? So then if there's no positional data on this, you just hear every sound in the environment all the time. Right? Everything that happens, mouses, squeaks, cricks, deaths, everything, right? So now you add sound positioning to it and sound occlusion to it, and you actually start getting relevant data. So now as a missile is moving through the environment, right, you've still got this system where you're pushing a binary stream of wave data down to the audio code, or the audio card, and the audio card is processing it. The difference is that each frame, you're adding a slight modifier to the next piece of data that's going through this channel. And so as you hear this Doppler effect of a missile coming by you, effectively what's happening is every frame you're evaluating this positional fall off to determine what the true vocal properties of this thing should be, or whatever graphs you need to attach to it. But in the background, the system is still just streaming the wave data through the sound system, if that makes sense. And then of course, if the sound ends, it loops. Right? You look more confused than you did first. I think that means I win. Instructor of the year.
Take the t-shirt.
No, just because. So you're saying the sound is not discrete chunks of data sampled through time. It's actually a waveform of some sort through.
The wave file.
Wave file. So most of your sounds should be pre-computed offline, right? Some artist or some sound designer sits in a room, plucks a guitar, makes a chicken noise. This is saved usually as an MP3 file or a wave file. This is then loaded up into the memory of your game, and then you actually say, "Hey, go play this sound." And what that actually does is that'll take that chunk of mostly sounds are scalar data, right? There's a number of channels of scalar data. It'll mem copy that down into the sound audio API, which will get moved itself into the audio chip, right? So then the audio chip is going to sit there, and for each of those scalars, it's going to push it into whatever audio processing it needs to do, and then that'll create the sound, right?
Yeah.
And so what happens is, like, as a rocket is moving, you're not sampling that data on the chip. What instead you're doing is adding modifiers to the data that's on the chip to change the output that's coming through the speakers.
Yeah.
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 Okay. I'm glad we agree. You're right.
Yeah, I'm not entirely sure. But
Okay.
yeah.
Okay. Teacher of the year. Yes.
I
No, Tony. No, hold on. We got another question.
So I kind of was thinking about something a little bit different when you brought up this question is if you've got a multiplayer map and you have somebody on the left side of the map and you have somebody on the right side of the map, and the person on the left side fires a missile and it starts to take off. Now it actually gets out of range of that particular left person's, or starts to get out of range of that left person's, I don't know, audible range,
Yep.
right? Do you ever have to worry about like restarting the sound such that it might still be partially in the first person's audible range, but the second player needs to hear it differently, or is it just not an issue because two sets of speakers totally different removed from each other? Is that really?
Yeah,
what it boils
you have
down
two
to?
observers.
Okay.
And each observer takes in their environment unique of the other observer.
Okay.
Unless you're doing like multi-screen co-op, which I think hopefully died with 007 GoldenEye.
Probably.
Star Fox, do a barrel roll.
Okay, fair enough. I just was trying to think through how you would do that logic.
Yeah, I think the main thing to keep in mind there is that you have one observer usually for the environment that they're experiencing. And so if I'm sitting here and I shoot a rocket and it goes out of my audio range, I'm done with it, right? And then if I'm on the other side of the room and he shoots a rocket and it's coming at me and I can't hear it, then all of a sudden I can. Each person is taking in their environment differently.
So everyone's mentioning, rockets flying across an open space.
It's very friendly and cuddly.
Right. Yes. Very, very friendly. This kind of makes me picture a very open space where you're in kind of an outdoor map, whereas when we were originally talking about this binary space partition, it's mainly an indoor area where you can very easily section everything off into rooms. Do you just have like a general standard tile size essentially, or space for each for open areas for determining where you can play?
Oh yeah, great question.
Yeah.
So most open area games don't make any more money by modifying the sound properties of an open terrain. So mostly it's like, hey, if you're outside, you shoot a rocket, you're outside. Usually they only start modifying the properties once they're inside. Now, that being said, they do set material properties so that when the rocket hits a chunk of meat, it does the right thing as opposed to hitting a rock wall. And if you play, Red Faction was actually really cool, is you could actually blow holes in the wall and actually start tunneling. And that was way before you kids had your Minecraft. That was back when tunneling meant something, because you actually had a limit.
Split screen PlayStation games.
Okay.
More questions?
All right.
Move on to the.
All right.
Onto the dory.
Yeah, somehow my youngest son plays music in this one room, but it's still as loud in the other room.
Your house has proper
Defies physics.
proper sound properties.
All right, let's see. The presentation view is
it working?
Yeah,
It's working
that's-
this time.
That's good.
Awesome.
All right, so
Oh.
question from Jörg from Austria. Would you recommend using Go instead of JavaScript on the server side of your game? And maybe do you also see a future for Go on games on the client side and on desktops or consoles? Go.
Yeah.
So first one, your mileage may vary is absolutely the answer to this. So for grits, the reason we chose Node.js and JavaScript for server-side language is because we could actually share our client-side code with our server-side code. That was actually important to us because we wanted to reduce the number of moving parts. We already had app engines. We were already writing a lot of Python code. We wanted to reduce what we were doing. Second part of the question, do you see a future of Go for games? Absolutely. In fact, all of you right now should have already played the amazing game called AirMech on the Chrome Web Store. AirMech is a real-time 3D, real-time 3D. It's a real-time strategy, 3D real-time strategy run inside of Chrome native client. And it actually uses Go for all of its server-side computation, which is fantastic because if you remember, a real-time strategy game usually uses a peer-to-peer network as opposed to a definitive server. So this makes sense for a real-time strategy game because it really doesn't have to do a lot of server-side compute. Basically just has to pick up the data from each of the round-robin items, push it up, and then propagate it to everyone else. So Go makes a lot of sense there. Having your client in C++ code and then trying to build an MMO server in Go is probably going to be very difficult for you because you basically have to duplicate all of your data structures for packet communication and things along those lines, and then duplicate a lot of logic as well. Typically when you run like grits or an MMO or a first-person shooter, you have to have the authoritative server where the server is actually computing the real game. The client is basically computing a one-off version, and then it corrects itself whenever the server sends an updated ping. So basically if you're writing in a language like Go, you have two versions of the same game. Right, you've got one in C++ that's actually highly optimized, and then one in Go that isn't highly optimized. And so, for the whole thing, is your mileage may vary, and what do you need?
Good. Maybe I'll take this one real quick, and then come back to it. The next one from San Francisco. Bastian Delitus. How does the submit a game for the contest and get a job at Google X program work? I can't find any more details since the top secret email.
You have invalidated your entry by talking about it.
That's right.
Top secret means top secret.
I have no additional information about it.
This is the first I've heard of this.
Me too.
First rule of Google X is you do not talk about Google X.
So, yeah. Sorry, had to hang up.
It's a great
Should have hung
great
up.
question.
Yeah.
I want that on a T-shirt.
Earlier you said to respect the type system even if it's not there when using arrays because that lets V8 make JIT optimizations. Can V8 optimize like that for custom data structures like linked list and trees too? What about other browsers from Flaze?
Great question.
Any ideas?
This is you, brother.
Yeah, I know nothing about V8.
I don't know either. So.
All right, I'll do this then. So the only time that V8 will actually make optimizations at runtime is for known math-based types. So int, float, double, byte, things along those lines. If it's not one of those basic data types, it assumes it's an object and just kind of lets it run through the standard properties. So a custom data structure, you're not really going to get. So V8 won't optimize your data structure further, right? That being said, I highly recommend that everyone in the room investigate alternate data structures when moving through your game process. I've talked about this before with linear growth arrays. Make sure you're taking a look at priority heaps, all these other sorts of things, because that's going to be where you actually get the most benefit from your memory usage and your performance profiles. So other than that, though, I guess there's just a clarification on making sure that it's typed data versus untyped data.
Yeah. Okay. Florian in France was asking about the Epic port to Unreal Engine 3. Mm-hmm. That's pretty cool. If you haven't seen that, definitely check that out. So Mozilla have recently announced they teamed up with Epic to port Unreal Engine 3 to JavaScript using ASM.js. What do you think about this approach, and how does it compare to native client?
Booyah. So actually, they unveiled this week at GDC, which is fantastic. I love GDC. And I actually had a great hour-long conversation on the show floor with the engineers. I was actually lucky enough to walk up and actually be able to talk to the Mozilla engineers who worked on the Odin Monkey side of things alongside the author of ASM.js and one of the dudes from Emscripten. So it was like my own little programmer holiday. I was like, I can talk to everybody. So there's a couple really interesting things. It's basically how this is working is that Unreal 3 has been known for a long time as the unwieldy beast that no one can tame. Right? Back when it was first released, it was pretty much the only thing that would run on the PlayStation 3 and made a lot of money because of it. Great tool chain, great artist flow, amazing way that data was produced. But programmers would just lament for hours and hours and hours about how difficult it was to get this engine to do exactly what they want. Of course, that was back in 2005. So the engine has had tons and tons of games shipped on it. They've made lots of modifications. When Epic actually started making their engine able to go to embedded systems, so when they actually made it work on the iPhone and then on Android devices, they actually did a ton of cleanup work. And then if you guys remember, about a year and a half ago, Epic came out and announced the joint partnership with Flash to actually get their Epic Citadel demo running inside of Flash's Flask compiler, which was effectively the Flash version of native client. You can actually run C++ code with a very proprietary API, and Flash would load that data up and actually execute at native speeds. So the interesting thing about that was that it was actually using an LLVM variant. So it was actually using the Clang compiler. So the guys over at Epic actually did a ton of work to get their engine actually working with the Clang compiler. So how this actually works today with the ASM process is that they will actually take that output of data, which is LLVM, and then they'll run it through Emscripten. Emscripten, I think we've all talked about before, will actually take your C++ code, run it through LLVM, and then produce JavaScript from that. Now that JavaScript, it's a build of Emscripten that'll actually add ASM.js annotations to it. So then you basically get JavaScript code that then has been annotated with hints. For those of you who don't know how ASM.js works, basically it's a hinting system to tell the underlying VM for JavaScript how to optimize the code. Of course, then it relies on the fact that your JavaScript virtual machine actually takes that into account. So what we saw on the show floor was this entire process. C++ to LLVM to ASM annotated JavaScript data running on a brand new build of the Odin Monkey virtual machine. And it was actually very impressive to see. They were actually able to run at about, I think 30 or 60 frames a second, which was great. And I don't think the networking component was in. It was just a single client, right? So they weren't doing WebSockets or anything along those lines. It was very, very impressive to see. There was a couple caveats from it, which I think and I spent a lot of the time talking to the guys about like where does this fail. First off, obviously it only works in Mozilla right now because Mozilla is the only browser that's actually adopted the ASM.js standard. Second off is that it really hasn't solved the memory problem, and native client has this too. This is one of the main things I harp on for web development is we still haven't figured out our distribution model, right? So that demo I think was somewhere in the range of like 256 megs or something like that. Right? They had to bring down like 18 megs of data before they could actually load their base binary to actually load in their actual binary data. For web distribution, this doesn't actually get you that far. And in fact, it actually doesn't run in Chrome at all right now because it runs out of memory. So obviously this is a fantastic proof of concept to show that these things work and that is doable. So when you talk to the Epic guys about why the Unreal Engine isn't ported over to native client, one of the first things they'll tell you is because it requires GCC. So GCC is a separate C++ compiler that has different requirements and annotations to it as opposed to Clang. So they already did all the work to make sure Clang works, and so this was actually just a natural progression, a natural step for them, whereas going through the native client process actually required them to go back and retool their code. So I think both methods are valid, and this is what I've talked about a long time, is that we need to stop talking about the language and we need to start talking about the data distribution model, right? So I think that what they quoted in the press release was that ASM.js modified Unreal going through Emscripten was getting about 50% of the speed of C++ code with O2 as an optimized compiler flag, which is fantastic, right? Like this is really, really cool. It proves that you can do super high performance stuff. As a game development community, I think we still haven't solved all the other hard problems, and you see this with ASM and native client and HTML5, which is that how do you transfer 500 megs of data to your client and actually expect to make money? So I think it's great. I think it's fantastic that we move forward. I really wish that we would not have to use JavaScript, though. I really am an advocate of moving towards something like a standardized web LLVM or something, right? Because if you start taking, and this is a rant. Yeah. The previous thing wasn't a rant. The previous thing was data. This is a rant. So if you actually start taking what we're doing towards the limit here, we're sort of, again, we're frankenbolting all these things back onto JavaScript, trying to make it catch up with all these native languages that already have support. So things like adding SIMD, annotated, oh my God, are you telling me that if I suggest types to my JavaScript and then annotate it, it could actually run faster? Who'd have thought? Right. For a long time, the web community was like, no, we don't want types, we don't want annotation, stay out of my kitchen. But now we're actually starting to realize to get that stuff we need it. So if we start moving this towards the limit, we actually see JavaScript code and these annotations start making more sense and actually starting to converge with what native code provides. And when it gets to that level, then you have to seriously start asking yourself, why do we care what language is going through, since we're just treating JavaScript like a VM anyway? So now we've got a VM on top of a VM. It'd be really good if we just knocked off that first VM and actually went to something in the medium ground. Instead of actually having a JavaScript VM, we just had an LLVM VM, right? And then this way you can actually take all of your existing code for whatever language you want, create whatever application you want, convert it to LLVM and have it run in native application on the web. And this is sort of the dream of the portable native client project, right? Where you can take everything, produce LLVM, upload it to a web page and have it go from there. I do think that in 5 to 7 years, this will be the thing. I think that we've got some prototypes internally at Google that show that it's a lot sooner than that. But adoption is adoption. So, again, my opinions are that of myself and not any organized body that I may be associated with. I added one today. I was any organized body, association, or secret society I may be organized with. I got a letter last week that told me I had to add that.
Okay.
From your secret society.
I'm not saying who.
Someone sent you.
It wasn't from Google X.
Okay, I was going to say. So this next question from Jimmy in Australia looks like something we talked about a little bit last week.
Yeah, we've actually harped on this. Well, not harped on it, but we've discussed it a few times, I think.
Yeah, maybe just briefly recap. If you have an idea.
So the question is, we learned earlier about tile mapping in the Atlas. Is it possible to do the same with audio? Would there be any benefit in having the audio concatenated into fewer files? So this actually is something that there are libraries out there that do this. The most recent one that I've seen is Howler.js, which will concatenate all of your different sound files into a single.
How do you spell it?
Howler, Howler,
okay.
JS.
Right.
And then it effectively acts as an atlas for your sound files. It says, okay, this sound is at this timestamp, and start playing here, and it basically wraps all of web audio and then falls back to HTML5 audio if that doesn't work. So it's actually pretty impressive, but I would say that's probably still very useful for exactly the same reasons that tile mapping is useful. If you have enough assets, then it's going to get painful to actually download all of those.
Awesome. Awesome. All right. And then check out last week's show as well, where we had a much longer answer to that question, Jimmy. I'd like to write a game that has in-game music, says Jimmy again, with songs that change depending on environment, dungeon, forest, etc. At a high level, how would you structure the music manager? Are there any gotchas to watch out for when playing in-game music? Do we have? These are like background music, kind of when you're playing a level.
I think this is actually like songs rather than
Right.
rather than background noise. So I'd say it depends on what level that you're talking about here. If you're talking about just playing these songs at different environments, then you just attach it as data to that environment. That okay, once you go here, then you play this song.
Right.
If you're talking about modifying them in some sense, like adding some effects to them based on what environment you're in, then I would say that it's
stuff that Colt was talking about earlier.
Then I think it's exactly the same thing.
Like the sandy room and the pool and everything.
Yeah, or if you're in dungeon or forest or whatever, then okay. Well, if you're in a dungeon, then you might want to make the sound a bit more creepy.
Now, there is a thematic version of this, is that you may want to take into account design information or state of the game to determine what background loop you're actually playing. So typically you've got instance-based music and you've got background music. And these are two separate things, right? Instance is play one or maybe play a few repeats but expects to die in the future. Background music you expect to just kind of be ambiently churning along, right? So if the question is, how do I modify my ambient background music based upon what's going on in the game? Effectively what you need to do at this point is make a weighted tree graph. Right? So you need to actually say, you need to create some sort of decision tree that says, if Spooky and Snow White, then play Snow White Spooky. If Spooky but Little Red Riding Hood, play a different one. Right? And typically these things should have some sort of weighted value to them that has an input from how your game is actually working. So for instance, you may say that spooky means that you are in a room that only has one door and there are more than 4 enemies in that room. Right? And so this is basically a binary or a scalar value that then gets pushed through your decision graph to determine what sound is actually needed to be played. This can actually get pretty awesome if used correctly. It can also really spiral out of control if used incorrectly. So make sure that before you sort of adopt this philosophy for your game, that you seriously consider all the pros and cons of like writing this large system, because you're actually going to start annotating a lot of data. You're going to start creating a lot of code paths to evaluate your environment and push the data through the system.
Cool. Very good. So this question just jumped up. I was reading the other one. This was upvoted. Colt, how do I get a job in the industry? Cliche question, but it's quasi-related to the course. Do you just go through Carmack and VS 2012 and read a book, or go through the Udacity course?
Fantastic.
Or both.
This is a fantastic question. I've said from day one that the best way to get a job in the games industry is to go out there and try to break apart and tear apart every game you see and rebuild it from scratch. Right? Look at exactly what they're doing and try to duplicate it. If you don't know how to duplicate it, go ask someone how they think they did it, and just rebuild. The way that I learned, the way that I've learned best, was actually looking at other people's source code. I've said this before, I think I actually taught myself 3D mathematics looking at the Quake 2 source code. Like, I didn't know Z-axis existed until I was actually like, hey, what's this thing? So that was my introduction to a very large problem space. But it actually came from looking at someone else's source code. A lot of the times you're going to run into problems when you're trying to create a game where the problem isn't algorithmic. The problem is you don't see where this goes, right? Like, you don't know what the end path is. So you don't know how to write the code because you don't know how it's going to be used or what the final manifestation is going to be. Getting a chance to look at other people's code is a great resource for this, because you can see where it goes through. There are hundreds of thousands of fantastic open source resources out there for this. Check out the Homeworld source code. Check out the Angel source code engine. Check out Impact.js. Quake 1, Quake 2, Quake 3, Doom 1, Doom 2, Doom 3 source code. In fact, I would really just go through Carmack's stuff and like the question said, learn his stuff, go through there, figure out how the pros are doing it, emulate it, fake it until you make it. Visit gamedev.net forums. Really, suck in as much data as you can. Start redoing it. When you go into your first job industry interview, they're going to say, all right, well, we have some questions here, and you're going to be able to say, yes, I absolutely know what that is. John Carmack used it in Quake 1, and he used it to this effect, and this is how it changed the game. Right, and that's impressive. That's what game developers want. To be fair, a lot of game development companies say that they want someone who plays games. That's a complete load of horseshit. Just to be frank about it, because of the fact that if you go home at night and you spend the next 17 hours of your night playing games when you could be programming, right? I don't care if you understand how the DPS value. If you're a designer, go home and play the games. But if you're a programmer, I'd rather have you go home and programming and learning and listening and making better and writing projects and doing awesome things, because you're going to outpace everybody else, right? That shows you're passionate about it. If you're a programmer and you go home and you're bragging right on your. I actually got a resume one time. That said his claim to fame was like, I have 15 level 80 characters in this MMO. And I literally took it and I just crumpled it up and threw it away. And I was like, this is fantastic, this is great, but your resume said nothing about binary space petitions, compression, technologies that make you passionate. How does diffuse lighting work? These things are what you do when you're not at work. And so that's my personal bias. I love people who code and who are addicted to coding, because that's who I am. A lot of companies say, we value people who play games the most. Really? Who gets the largest bonus at your company? Because I'll bet you that guy goes home and still works. I bet he doesn't go home and play games. Unless it's the CEO.
Yeah.
So a quick question from Florian in France. About the contest, is it cool to make a screencast to briefly explain how the game was made? Or does a video of the gameplay, is that relevant enough? So obviously for the contest, and the rules are on the Udacity
wiki.
The wiki. Obviously we'll need the actual game. But, I'm assuming that's the case. But having any additional information, such as like a little video on how it was made or how it's played, is obviously helpful. I think last week we had a question about what about documentation and other bits and pieces that, or even code commenting styles and so on. Clearly, those will all be bonus points, but the real crux of the matter here is the game itself that we'll be judging. So just the video itself is not enough, but having additional information and other cool stuff will obviously be taken into account.
Yeah.
Right?
Yeah. But the most important thing is the actual game
itself, right?
The source code.
Yeah, exactly. And then next question also from Evan in Washington, D.C. For the contest is, if a friend provides sounds for me to use in my game, must he also be enrolled in the course, and if he's not doing any coding? So the answer there is no. Maybe if you want to keep him as a friend, you might mention him in the credits.
I got a ticket to I.O., son.
right. Anything to add there?
No, I think that's fine.
It would be the same as finding sounds on freesound.org or buying them. So really,
I don't have a problem with that.
But yeah, that's how that works. Okay, we've got quite a few questions coming in. I've created a rain effect class. This is from Michael in Israel. I've created a rain effect class. In every instance, it fills a triangle with random blue gradient at a position. It looks nice, but I want to make it better, like we see in the game. Is it the shade 3D environment factor, and any tips to make it more awesome?
Absolutely. Go check out a book called Shader X2. I think like chapter 3 or 4 is actually how to make realistic rain simulation on glass.
Is that a book on the list?
It is, yeah. If you go down the list, the Shader X series. So Shader X is a graphics series, or it's a series of books built for graphics programmers, and it started back in the day when programmable hardware first came around, right? So back when normal mapping was only setting textures, and it has progressed all the way through. I think like Shader X 9 or 10 now, where we've got fully compute pipelines with tessellation shaders and all this other fun stuff. So, but Shader X2 is actually the one you're looking for, because there's an article in there on how to do this. Effectively, what you're looking to do is the blue is not what really makes it look like rain. What makes it look like rain is actually the refraction of the light through the drop of rain. And you'll actually find out that all the really good water simulations take the background environment and then modify how that's rendered through the raindrop, and that's what gives the rain its nice curving. That's what makes it look like it has volume and properties, that you're actually seeing light being refracted through it in proper manners. That's really what you're going to go for, and that book actually talks a little bit about how to do that.
Right, and the list I was talking about is on your Google Plus.
My Google Plus
Right.
stream, Colt
Getting
plus
a
Colt
lot of free
McCandless.
shares. So basically, Colt put together a list of all the important game development books. People are adding to it. Definitely check that out on Google Plus. Are you on your vanity URL yet?
I am, yeah.
Good.
Yeah.
All right. So google.com/plus
Colt McCandless, that's
There you
right.
go.
Okay. Yeah.
We're now rolling those out. All right. So 2 more questions, and of course, if you have a question here in the audience, please feel free to jump up to the mic.
You got a question?
New
Microphone.
programmer from Maine. I just know HTML and CSS. Is there a pre-requirement for developing HTML5 games? I guess the answer would be that's a good start, but obviously you're going to need some JavaScript. I mean, if you go through some of the introductory lessons, we're trying to kind of get you up to speed as soon as possible, but you're going to need a fair amount of JavaScript on top of what you already know.
Yeah.
But definitely not a bad place to start with this very course.
Yeah.
Anything?
Yeah, I'd say knowing some more JavaScript is definitely important. I mean, writing a game is a difficult thing, and trying to learn a language while doing that is much harder. You can do it, but it's going to be a lot of work.
And then, of course, the question we've all been waiting for. That's what has been on everyone's mind, probably on the thousands of people on the live stream. They want to know, Colt, you talk a lot.
Yeah,
That's
happens.
not a bad thing. I have a question. Are you incapable of giving a one-word answer? If no, you can't say yes, but you'll have to explain.
We got to get the name on this.
Oh yeah, this is Flays, who's been very active.
Yeah.
I do have
Question.
to. I have to say that I'm very happy that there's more down votes for this one than up votes.
We need to fix that.
Yeah, thanks. So I'm very happy with that. I am capable of giving a one-word response. However, I find that mostly is inefficient. Generally, when someone asks you a question, there's context involved. And it's either their context in asking the question that you don't have enough information about, or it's your mental model needing to be explained to them. Humans are binary trees, and we got to make sure that their mental models match. That's the only real way we communicate. So when I answer, I try to put as much context around the answer as possible, because I think that actually matters. I'm sorry, your hand's up. You got to go to the microphone.
Yeah.
And that's why story time with Colt is
That's
a
why
thing.
that's why story time with Colt's a thing, because I try to put as much context there as possible.
Over at the HTML5 conference next door, Philippe Lehegere, who is the domain leader for the World Wide Web Consortium out of MIT, was talking about the future of video. And for those of us who want to use video in their games, the question would be, it seems to be some debate as to whether time text markup language, TTML 1.0, or the SMPTE TT standard are going to prevail. And mostly what was interesting was WebM video, which I use all the time, apparently is some kind of a licensed thing that may not be ultimately part of the standard. So the question is, if you're going to use video, what are the safest codecs to go with?
Wow.
This information's about a half an hour old, so I don't know if that's
Yeah.
news to you
Yeah.
too.
I think it's worth starting out first off is that none of us are legal counsel.
Yeah.
Just to make sure
you.
that that's out there. None of us are legal counsel. Anything you do with our feedback is your own. If you choose to jump off a bridge, that's on you. I didn't know that WebM had a thing. I hadn't heard about that.
It involves Nokia. It's
interesting.
definitely. I talked to him. I talked to him after the conference. He said it is a licensing issue.
Interesting.
Go ahead, please.
Sorry, so
Could you come up to the mic so
Oh, it's
people on
just
the
the
live stream
VP8.
The
can-
VP8 codec.
VP.
Right.
Okay, that makes sense.
Okay.
Yeah.
Yeah.
So SMPTE TT versus the TTML for use of video in games. Is there any comments on that at all?
I have none.
Yeah.
Typically, we use Bink.
Yeah. Bink is has been pretty standard for a long time in games.
Yeah.
Right.
Most GPUs have H.264 hardware decoders now. This is like the technology that Gaikai and OnLive were built on. But as far as software standard, I got nothing.
Thank you.
You're talking about specific for web video, basically?
Yes.
Yeah.
Building something, designing and building something now that 2 years from now isn't going to be obsoleted because the standard shifted on us.
Yeah.
I think that's going to be true regardless.
I was there, but I'm done. I'm done.
All right, thank you.
Sorry I couldn't be of more help.
Yeah.
Thank you.
Yeah.
All right.
Hi. Short questions. How the HTML5 support to the WebSocket performance and code? Can you explain it more detail or long question, long answers?
Awesome. She wants long answers. Fantastic. Round of applause for that. Yeah. Unfortunately, I'm the wrong person to ask about WebSockets. This guy is.
Guy is, yeah.
So,
Done a little bit
so
with
how about a long answer from Peter? Will that work?
Yeah.
Well, what do you want to know? So one of the things we didn't cover in this first Udacity course was, because it's a client side only, is that the sort of the connections with the server for which you would want to use WebSocket wherever possible. Basically, WebSocket gives you that bidirectional socket connection with the server, and so. But I'd like to understand a little bit more what your question is about. Can you add a little bit to it?
How to support the WebSocket performance?
How to support WebSocket?
The performance.
WebSocket performance.
The performance implications.
Yeah. Okay. So WebSocket really gives you two important details when it comes to performance. So the first thing is, if you think about what you would do without WebSocket, you would be using an AJAX call, maybe something like a hanging get or pending post. So you basically send something to the server, and then the server just sort of, like, it's basically a poll to the server constantly. And every time the server comes back with something, and people have gotten quite adept at making it better than just straight up polling. But every time you poll the server, you make a request and the server gives you a response, like an HTTP get and then a response from the server. And that typically is coupled with, easily 1,000 or 2,000 header bytes. So your request comes with an overhead. So even if you say, here's my X and Y coordinate, you're actually sending a get with another 1,500 characters to the server. Server says, oh, okay, great, I got that, and here's another 800 characters. So for the 3 characters that you wanted to send, you're now sending 1,800 of packaging, right? So to solve that, WebSocket gives you set up a connection. So your client game creates a connection. It then creates this end-to-end socket, and after that you can send messages that have minimal overhead. I mean, we're talking of just a few bytes, right? So WebSocket, the messages you're sending over a WebSocket are still framed, but they're framed with just like a few bytes. Like, think of 4 to 8 bytes in the direction to the server, a little bit more, and on the way back, not even that many. So you're cutting down a tremendous amount of unnecessary overhead. So that's a huge performance gain, of course. And then it's also more direct, because you can basically add an event handler in case messages come in. You say, okay, well, great. I immediately receive that, as opposed to the poll, which may have a timed interval and say, okay, I'll poll every 10 seconds. And if you poll just 1 second too late, you're waiting for 9 seconds for the data to come back. So that's a huge performance upgrade, of course. So it's more direct, less overhead, and those are some of the advantages. And then typically, you would run this over what is called WebSocket Secure, WSS. One of the big downsides of WebSocket is that if you send that initial request to set up the connection, you often, that's actually done with HTTP header. So you create an HTTP request that says, upgrade me to WebSocket, and then on the way back it says, okay, you're connected. Now you have this socket connection. Upgrade headers are by spec ripped off of all of but throughout the proxy server. So a proxy server, per the specification, will remove an upgrade header.
That's cool.
Now you can understand what happens, right? So the request never ends, or the request comes to the server, but it's no longer asking for the upgrade. So you've lost that and you create a bad connection, or you don't get a connection at all. Some proxy servers are actually illegally configured to not rip them off, which is actually worse because now it gets to the server says now you have the connection, but the next thing it's expecting is the proxy is expecting HTTP headers, and it's getting a WebSocket frame, so it's going to barf and just choke on that. So to counter that, to get a much better penetration, you would use HTTPS or TLS, effectively, a secure connection, which effectively first sets up an end-to-end socket connection, and then you start sending the HTTP headers over that to connect the WebSocket, and then you're connected. And that's actually not as much slower than most people expected in general. And in fact, you can see that the same idea is used in Speedy. It starts with a secure connection and then goes a lot faster, and like multiplexing and so on. So it has many benefits apart from it being more secure. So that's another additional little note there. So.
I will add two things to that. Peter is awesome, and I love his explanation. I will add two things to that. The first is that when you receive your callback from your WebSocket that actually has your packet of data in it, you need to be very sure that you cache that data off immediately, as opposed to actually processing it and handling the response when you get it. As we talked about a couple weeks ago, that callback can actually push back your request animation frame, which is going to make you skip a frame. So effectively what you want to do is, as soon as that response happens, you just pin that in the heap or in some other FIFO array or something. Number two is that you need to make sure, a continuation of number one, is that you need to make sure that that data isn't creating duplicate copies or excess garbage under the hood, because when you actually copy that array, you may have a bunch of little free objects sitting around that the garbage collector is going to go crazy on here in a little bit. So that needs to be taken into very careful account as well. So the second thing is that, as Peter mentioned, the number of bytes that are added per frame is actually pretty low. However, it is something we did optimize for on grits, because the number of packets we send is actually pretty large. And so what we actually had to do was start batching all of our packets together so that you would see move, shoot, add, move as one large packet that was sent across. Because we would send 32 packets, but that's per byte on the beginning, byte at the end. That's an extra 64 bytes that's going across the wire. So we did optimize for that. And there's actually more of that data if you check out my Google I/O 2012 talk on grits. I actually go into that in a little bit more detail.
Yeah, and also now you can use WebSocket started out as a text-only protocol when it was first released, but now you can send binary data. Yes. So a lot of people would first, like say an image or something, they would maybe base64 encode it or do something to send it across as text. You no longer have to do that. So that's kind of important as a obviously optimization right now. Good.
Yeah.
All right. I think we're over time. Thanks for the great questions. Wanted to one more reminder about the contest. If you are, if you have one more week or so, and you want to participate, it's not too late. It's getting very hard, very soon. It will be too late.
It's going to be a little hard,
but it's still possible. You can look at the wiki for on the Udacity site for details. We have some great prizes: ticket to I/O, a cameo appearance on one of the future Udacity training videos, lots of cool hardware prizes. So definitely do what he's doing in the audience and write cool games. So yeah, next week will be our last session. That's pretty amazing. It's been a real blast for us just to be here, especially everyone that's here now is really in it till the end. So thanks again, and look forward to seeing you next week, same time and the same place.
Okay.
Thank you all.